Hello, welcome back. In this video we'll discuss the dielectric materials and their basic definitions. A dielectric is a special type of insulator. If you remember, we have classified the materials using their electrical properties as a parameter into conductors, semiconductors, and insulators. A special category of insulators are called as dielectrics. All dielectrics are insulators, but all insulators are not dielectrics. In a dielectric, the electrons are bound to the molecule, which means there are no free charge carriers in a dielectric. These charge carriers include the electrons and holes. We do not find electrons and holes. The dielectrics are non-metallic materials with high specific resistance, and they have negative temperature coefficient of resistance. Dielectrics are a special category of insulators, and we do not find free charge carriers in the dielectrics, and all the electrons are bound to the parent molecules in the dielectrics. The dielectrics generally are non-metallic materials with high specific resistance and a negative temperature coefficient of resistance. Let us try to recall certain basics. We'll start with an electric dipole. This type of a structure constitutes an electric dipole. In an electric dipole, we have equal charges plus q and minus q. They are separated by a finite distance. In general, the charges and the separation are small. When two equal and opposite charges are separated by a small distance, then you call such an arrangement as an electric dipole. Two equal and opposite charges, small in magnitude and separated by a small distance, constitute a dipole. To be precise, an electric dipole. We also have dipoles in magnetism. So two equal and opposite charges that are small in magnitude, which are separated by a small distance, they constitute an electric dipole. A dipole will have a dipole moment. The dipole moment is represented with a mu. Say if q is the charge, the magnitude is q and the separation is d. If you take a product of the charge times the separation, that gives us the dipole moment. The product of magnitude of both charges and their distance, it is called the dipole moment. In this case, the dipole moment mu is equal to qd, where q is the charge on either of the charges and d is the small separation between the charges. Now we shall see the dielectric constant. The dielectric constant is the ratio between the permittivity of the medium to the permittivity of the free space. If epsilon is the permittivity of the medium and epsilon 0 is the permittivity of free space, then you call the dielectric constant epsilon r as epsilon upon epsilon 0. Epsilon r is also called as relative permittivity. So it is defined as the ratio between the permittivity of the medium to the permittivity of free space. So epsilon r is epsilon upon epsilon 0. This is called as an epsilon. Permittivity is a material property. If you have a medium which is a dielectric, and then its permittivity, if you call it as epsilon, and if you take the ratio between epsilon and epsilon 0, which is the permittivity of the free space, then you get the dielectric constant or relative permittivity. Now we shall discuss electric polarization. Suppose you have an atom. Say it has nucleus like this, and all around that you have the electron cloud. And if you place this atom in an external electric field, the nucleus will be displaced from its mean position and slightly moves away from its mean position, and you have the electron cloud changing its shape into something like this. If you draw a vertical line that is passing through the center of the atom or a molecule, then you see that this side of the molecule is relatively positive with respect to this side. This side will be relatively negative. A small positive charge seems to be present here, and a small negative charge appears to be present on this direction. And the separation will cause the production of a dipole in a molecule when the dielectric molecule is placed in an electric field. The electric field we are applying in this direction. The electron cloud is attracted to this side and the nucleus is relatively pushed away from the mean position. So this constitutes a dipole, and in a piece of material we have several such molecules. The process of converting dielectric molecules into dipoles is called as electric polarization. The electric polarization is defined as the process of producing electric dipoles which are oriented along the field direction is called polarization in dielectrics. So you have neutral molecules. We are placing them in external electric field. As a result, a portion of the molecule becomes relatively positively charged and the other half of the molecule becomes relatively a negatively charged region. This constitutes a dipole. Process of producing electric dipoles which are oriented along the field direction is called polarization in dielectrics. Now we define another quantity called as polarizability. The polarizability is represented using alpha. If we increase the electric field intensity, the separation between these two regions also would increase. Means the dipole moment also is increasing. The changes in dipole moment are proportional to the applied electric field. The proportionality constant is called as polarizability. It can be defined as the induced dipole moment per unit electric field. Polarizability means the induced dipole moment per unit electric field. Now we shall discuss the polarization vector. It is represented with a P. The polarization vector is defined as the dipole moment per unit volume of the dielectric. It is defined as the dipole moment per unit volume of the dielectric material is called the polarization vector. You have a dielectric material in a parallel plate capacitor, means the material is placed in an external electric field. So each molecule is becoming a dipole. One can estimate the dipole moment per unit volume, and the dipole moment per unit volume of the dielectric material is called the polarization vector. Mathematically, P can be written as n mu bar, where n is the number of dipoles per unit volume and mu bar is the average dipole moment in the given material. The electric flux density or the electric displacement. It is represented with a capital D, which is a vector quantity. The electric displacement of a dielectric is defined as D is equal to epsilon R epsilon 0 E, the applied electric field. Epsilon 0 is the permittivity of the free space, epsilon R is the relative permittivity. So the product gives us the permittivity of the dielectric. So this will be equal to epsilon E. So when you place the material in an external electric field, the polarization measures the additional flux density arising from the presence of the material as compared to the free space. So we write D as epsilon 0 E plus P, that is the polarization vector. And we know that D is equal to epsilon R epsilon 0 E. So you write this as epsilon R epsilon 0 E, that is equal to epsilon 0 E plus P. So you write the polarization P as epsilon 0 into epsilon R minus 1 into E. In this fashion also one can express the polarization vector. We also have electric susceptibility represented using with a 𝝌e. Mathematically it is written as polarization P is equal to epsilon 0 𝝌e capital E, which gives 𝝌e is equal to P upon epsilon 0 E. We know that P is equal to epsilon 0 into epsilon r minus 1 into E upon epsilon 0 E. So this will be equal to 𝝌e is equal to epsilon r minus 1, which is called the electric susceptibility. In this video we have seen what are dielectrics. We have said dielectrics are special category of insulators, and in dielectrics we do not find free electrons. Electrons are bound to the molecules of the dielectric material. Generally the dielectrics are non-metallic materials with high specific resistance, and they also have negative temperature coefficient of resistance. We have seen what a dipole is. If two equal and opposite charges small in magnitude and separated by a small distance constitute a dipole or an electric dipole. Every dipole will have a dipole moment. It is the product of magnitude of charges and their distance. It is represented with a mu. Mu will be equal to QD. We have defined a constant called dielectric constant. It is defined as the ratio between permittivity of the medium to the permittivity of free space. Epsilon r is equal to epsilon upon epsilon 0, where epsilon is the permittivity of the medium, epsilon 0 is the permittivity of free space. We have seen what is electric polarization. It is the process of producing electric dipoles which are oriented along the field direction is called polarization in dielectrics. We have also seen polarizability. The induced dipole moment per unit electric field is called polarizability. We have seen the polarization vector P. The polarization vector is defined as the dipole moment per unit volume of the dielectric material. It is represented with a capital P, which is equal to N mu bar. We have seen the electric flux density or the electric displacement. From that, we have obtained expression for the polarization vector. We have also seen the electric susceptibility. We have obtained 𝝌e, the electric susceptibility, as epsilon r minus 1. Thank you.